Hello dear students, how are you? Hopefully you are well. Welcome to Milestone family and I wish your ultimate success. This is your mathematics lecture and this is the lecture number 1, and this lecture is totally depend on your chapter 1, that is matrix. And generally one question always arises in your mind, that why we are just learning for this chapter, or what's the real implementation in our real life in this chapter, especially when we are talking about the mathematics. That's why I am going for some objective, that is this matrix will be helping you to solving the system of linear equation. It's a very important thing. Then in the probability tree or the theorem, which generally is the branch of statistics as well as mathematics, higher economics, and very interesting part, that is the hacking or the password breaking. So at the case of hacking, you must have to know at least 30 programming languages. At the same time, you have to expert in CSE, and on the time you must have to go for a course of matrix. So if you are thinking about the engineering sector, then the matrix will be very important for you. Okay, and the last part is to know the exact position of any objective or the person in a group. Okay, so this is our main objectives of the matrix. Now one question, that is, do we go for the definition of matrix or not? No, we will not go for the matrix, the definition of matrix. We'll go for a system of linear equation. Okay, suppose a system of linear equation is a1x b1y c1z equal d1, a2x b2y c2z d2, a3x plus b3y plus c3z is equals to d3. Suppose this is a system of linear equation. In this system of linear equation can be written as with the help of matrix like this way, that is a1 b1 c1, that is just this coefficient of x, y and z. Similarly this and this. So we can write it. So a1, now a2, now a3, b2, b3, c2, c3, and here is our the total 3 variables. Those are x, y and z. So it should be written as like this: x, y, z is equal to our third part, that is d1, d2 and d3. Okay, so look at the part of here. This is the system of linear equation, and this system of linear equation can be written as like this way with the help of the matrix. Maybe one question is raised in your mind, how this actually come and which way it comes. Don't worry about it, this will be discussed with our matrix multiplication part. Okay, now in this part where there is some entries, which since this already have talking about this are the matrix, so all of the elements of this are known as the entry. All of these are known as the entry. So a1, a2, a3, b1, b2, b3, c1, c2, c3, all of these are entries since this is a matrix. Similarly, since this and this are also the matrix, that's why this also is our 1 entries. Okay, now we are going for our matrix. Is which kind of matrix we are talking about? Is this a square matrix or is this a rectangular matrix? Okay, my dear students, we are just going for a figure. Okay, if we are just thinking that these are the just figure, and if I talk with you, or if I tell you that whose are the square and whose are the rectangle, then can you tell me that which are the square? I know that you can tell me that these are the square and these two are the rectangle, isn't it? Yes, this is the square and this is the what? Rectangle. In the square there was every side was equal. Every side was equal. Since in our square every side was equal, in this part if every part of this are equal, then we can say that this is the square matrix. Okay, maybe one thing is arise in our mind, that which part we are talking about. Here is two types of part, isn't it? One part is staying x-axis and another part is staying y-axis. Or if I am just talking with this part with very precisely, then we may talking about there is some values are remain horizontally and some values are remain what? Perpendicularly, isn't it? Okay, so these horizontally lines are known as the row. What? The row. So row are remain horizontally, that means it generally remains it in our x-axis way. Where we are just talking about, we know that this is our x-axis, this is our y-axis, so which value are remain parallel to x-axis, all are known as the row. So can you understand which are generally known as the row? Okay, now our second thing is which are known as the column. Column generally remain in our y-axis, that means the parallel line of y-axis, all of these are generally known as the column. So these all are the column. So in this matrix, what we gonna say? We can say that there is 1, 2 and 3. So there is 3 rows, exactly, there is 3 rows and 1, 2, 3. So here 1, 2, 3, I mean there is 3 columns, isn't it? So we can say from this matrix that here is 3. Okay, so what we are just talking about, these are the columns. Okay, so in this matrix we can say there is 3 rows and 3 columns. Now what about this matrix? In this part there is 1, 2 and 3. So there is 3 rows and only 1 columns. So this matrix is 3 rows and 1 column. Here is 3 rows and 3 columns. And here what will be the rows and columns number? Can you tell me? Yes, I know you can understand that these are the rows. So there is 3 row and 1 is column. Maybe one thing is arranged in your mind, what we are just going for. Here is 3 by 3, 3 by 1 and 3 by 1 we are writing. What is this? This is the order of the matrix. We are just talking about the order of the matrix. Order of the matrix. Okay, order of matrix. So order of matrix generally written as m by n. Though we are write it as multiplication, that is it should be 1 into m, or sorry, m into n, but it should be written as m into n, but we have to call it m by n matrix. Clear? So the order of a matrix always generally row by column. So m is the number of rows, m is, or m represents the row and n represents the column. So since in this matrix here was 3 rows and 3 columns, that's why it was 3 by 3. Here 3 rows and 1 column, that way it was 3 by 1, and here 3 rows and 1 column, that was it was 3 by 1. So these are the order of the matrix. So I think you can understand what actually the order of matrix. So one question for you, that is, if any thing looks like, suppose this way, A, B, C, D, and if something like this way, A, B, C and D, E, F, then what should be the order of this matrix and what should be the order of that matrix? Can you? Yes, I can understand that you can, because you are just thinking for there is 1, 2. So 1, 2, there is 2 rows, and 1, 2. So there is 2 columns. So it is 2 by 2 matrix. So the order of this matrix is 2 by 2. But at the case of this, here there is 2 rows, but there is 3 columns. So it should be 2 by 3. So sometimes you are very much facing some problem that which one should be written at the first part and what should be written as the second part. No need to worry about that. You should have to memorize this by this way, RC column, isn't it? We have drank this soft drinks for a lot of time. That is the RC column. So RC, that means the row and then the column will come. So at the case of order of the matrix, our order of the row will come in front and then the column will become. So these are the rows, these are the columns. So rows come first and column should be come for the second part. Okay. Now I was talking about two types of matrix. One is square or one is rectangular. So I think you can understand which one is the square matrix and which one is the what exactly rectangular matrix. Here this matrix known as the square matrix and this matrix known as the rectangular matrix. Rectangular matrix. Okay, my dear students, I wanted to make you track back. I never give you the definition of matrix, isn't it? I never give the definition of the matrix, I will just understand you what actually or how it actually works. By this way, already by this way we can tell you the definition of the matrix from 1 minute or to 1 minute. That is, this is the square matrix, this is the rectangular matrix. Why? The main reason to be it is a square matrix is the number of rows is equals to the number of columns. Okay, if in any matrix or any arrangement there is the number of rows and the number of columns are equal, then on the time we can say that is the square matrix. So the first and foremost rules to be a matrix, to be a square matrix, is the column number and the rows number are equal. So this is also a square matrix, this is also a square matrix, because it was 3 by 3 matrix and this is 2 by 2 matrix where rows and columns are equal. Okay, and why this and this are not square matrix? Because the rows number and the column number are not equal. If the row and column are not equal, then those matrix will be known as the rectangular matrix. Okay, so now come to the main point. If there is some entries, organized in such a way or organized in with some rows and columns with using what? With using first bracket or third bracket or double vertical bar, that generally known as the definition of a matrix. Okay, so we have already given the definition of the matrix. Just look at the matrix definition. That is, a matrix is a rectangular or square. Only two types. Just remind it very clearly. Matrix is a rectangular or square. We have already seen that. The array which is generally formed by arranging what? It can be some numbers it can be some variables, or it can be some expressions in a number of rows and columns, and it should be enclosed in used first bracket, third bracket, or double bar parallel line by both sides. Okay, now we are just giving two examples for understanding all the parts. If I am just going, or I try to actually impose to you the definition of this matrix to your mind, then it will be very much difficult for you, because there will be some things, suppose the rows and columns, this will be the arranging, there will be some brackets, and also there is given some rectangular square part or arrangement, so it can be confusing. That's why I have been given some examples to understand the basic of the matrix. Okay, so now here we are just giving two examples. It can be suppose 1 2 3 4 5 6, and here 1 2, it can be written as not 1 2, like this 1 2 3 4. Okay, so these are the arrangement, isn't it? And this arrangement is for numbers. So arranging some numbers, so we have just arranged some number, and these numbers of rows and columns. So in this arrangement there is some rows. How many rows is there? There is actually 1 2, so there is 2 rows, and 1 2 3, so there is 3 columns. So now our definition is also talking about this, that is the arrangement sum, or arranging some numbers in having rows and columns with must be enclosed by first, third, or double bar. So if anyone going for this, it will be okay, but if anyone tell me or tell you that if I am going for this way, then that will be also okay. But if anyone talking about no, I am just going for this way, or I will enclose the part by this way, then both three are okay. To define a what? Matrix. So this is the way to express a matrix, where we may also give this. This is also a matrix. So these two are the matrix. This is what, there is 2 rows and 3 columns, so it will be 2 by 3 ordered matrix, and this is 2 rows and 2 columns, so it should be 2 by 2 or 2 by 2 ordered matrix. So what should be our assumption to observing these two? Which one is rectangular and which one is square? Should I tell you? No, I know that, because we have already known that the square matrix, the rows and column must be same, but at the case of rectangular, the rows of column will not be same. So this is our rectangular matrix, and this must be our square matrix. Okay, now going to the definition for the again, that is a matrix is rectangular or square formed by arranging some numbers, variable expressions in a number of having rows and columns. There is some rows and columns enclosed it use some first bracket, third bracket, or double bar by both sides. So we have using this. So this is the definition of the matrix. And if anything like this 1 2 3, this is known as the row matrix, because if any matrix having one row, that is the row matrix, and if any matrix looks like this matrix known as the column matrix, because this matrix having one column. So the definition for row matrix is there will be only one row, and the definition of column matrix is if there is existing only one column. So this is the two definition of rows and column matrix. Now we are going to a very important type in this matrix part, that is square matrix and some parts. Okay, now suppose a one matrix, okay, just erase all of this for our better understanding. Suppose A is denoted for a matrix looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is a matrix having 3 by 3 order, or this is the square matrix of ordered 3 by 3, where 3 rows and 3 columns. In this matrix is known as the square matrix because of its same rows and column. So we can understand the square matrix. Okay, now we are going for the second term, that is a diagonal matrix. Okay, so in this matrix, row must be equals to column. This is our square matrix, and in this diagonal matrix, this diagonal matrix must have to be a square matrix. So in any square matrix, if only the principal diagonals entry are non-zero, those matrix are known as the diagonal matrix. What we have been talking about, a very important part, that is principal diagonal. Principal diagonal. What is the principal diagonal? My dear students, when we are going for a square, we know where is the diagonal. The diagonal must have to be this way and also this way, but at the case of matrix, these entries are known as the principal diagonal, and here, so, and these are, so I mean this part are known as the secondary diagonal. These are known as the secondary diagonal. So this is the principal diagonal. So the entries which are remain at the place of where the rows and columns part are equal, those are known as the what? Those are known as the principal diagonal. Okay, so what will be the trace? What will be a trace of a matrix? Trace of a matrix is the sum of the principal diagonal, sum of the entries which are remain in the principal diagram. So this the trace of this matrix will be 1 plus 5 plus 9, that is 15. So sum of the entries of principal diagonal. Okay, now one thing may be arised in your mind, that is why these are the principal diagonal and why we are talking about same rows and column position. What? Okay, I am just clearing this part. Suppose if there is an example looks like this, and if I am going for the position of that part, so mind it, 1, 2, 3, 4. Okay, so we are just going for our first row, first column. So which is our row? This is the row and these are our column. So this is the first position of the row and first position of the column, but this is the first row but second column, isn't it? This is the first row but second column. Here it is the second row but first column. This is the second row but first column, but this is our second row and second column. Okay, so just make it clear that this is the entry and here will be an entry. These two entries, our row and column are equal. Here also the row and column are equal. So that's why these are called the principal diagonal, where row and column number are equal. So in this part, if we are talking about, this is the position for what? This one, which says the position is 1 1. This is the position of one row, first row, second column. This is, or this should be our first row and third column. Here it is second row, first column. It is second row, second column, and here it is second row, third column. Similarly, here is also third row and first column, it is third row and second column, and here is also third row, third column. If you have any confusion, just remember for your kind information, that is, this is our row 1, this is our row 2, and this was our row 3. Here was our column 1, this was our column 2, and this was our column 3. Okay, so 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. Look at the part of the row and column position. It is 1 1, it is 2 2, and this is 3 3. I was talking about where the row and column number are equal. Those are known as the principal diagonal. Okay, so that's why we are talking about this is our principal diagonal where I is equals to j. What I is generally known as the row and j is denoted as the column. So it can be I into j, so I equals to 3 and j equals to 3. Okay, now the square matrix is this. At the case of diagonal matrix, this will be turns into 1 0 0 0 5 0 0 0 9. This would be our diagonal matrix. Why? The principal diagonals are non-zero, but others are always 0. If there is a square matrix whose the principal diagonals entry will be exist and others are non-exist or others elements are 0, on the time that matrix is known as the diagonal matrix. Clear? So diagonal matrix must have to be square matrix, and that square matrix will be the principal diagonal are non-zero. So two category we have to remember. One is this is a square matrix, and second is the diagonal entry or the principal diagonals entry are non-zero. Okay, now we are going for our third part or third matrix, that is square diagonal. Now scalar matrix. Okay, scalar matrix is something like this. So in our diagonal matrix, for the scalar matrix, we have to give the definition like this way. If any diagonal matrix, the principal entry has the same number or same entry, that is called the scalar matrix. So look at the part. First we are talking about this square matrix. On the square matrix, the principal diagonals, the principal entries or the value, those are the diagonal matrix. And in this diagonal matrix, if all the principal element or the principal entries have the same values, then that is called the scalar matrix. And if all the values are, or all the values of the principal diagonal entries are 1, that is called the identity matrix. My dear students, it's a very important part for us when we are talking about second year, and there is the real numbers. There is some real numbers rules and real numbers some properties. On that properties we must have to know the identity. So identity has a huge discussion, and I will hopefully give the explanation about the identity. Just you have to remember, in the identity that must be a diagonal matrix, or that must be a scalar matrix where all the values of the principal diagonal entries must have to 1. If these are 1, then that is called identity matrix. If these are the same values, this is called scalar matrix. If the if the principal diagonal entries are non-zero, that is called the diagonal matrix. And finally, the diagonal matrix or the square matrix will be those matrices where the rows and columns will be equal. It's a very interesting and very important matrix also. Hopefully this is our first lecture. So I think that's all for today, and our second lecture or second part we will discuss about the next parts. So stay home, keep safe. Thank you.